This video provides a solution to the end of chapter questions and problems 13.14. We're going to use the option portfolio workbook to answer this question. Today is December 16th, 2024. The asset price is $100, its volatility is 20%, and the risk-free interest rate is 5%. So the first thing we do is we make sure that the option portfolio workbook and the question have the same market data. So I switch to the spreadsheet and I look, and we've got today, today is 16th December 2024. The asset price is 100, the volatility is 20%, and the risk-free rate is 5%. Okay, so the market data lines up. You are long 1,000 European call options with strike 100 and maturity December 16th, 2025. Okay, so let's go look again. We're going to book an option position. We are long 1,000 European call options with a strike of 100, maturity December 16th, 2025. We'll book those at fair value. So I'm putting those into the spreadsheet. And we've got our Greeks for the portfolio and our option position and the payment for the option position. Net present value 0. Okay, so the question asks us, according to the Black-Scholes-Merton framework, what P&L do you expect from continuously delta hedging your position today? What the framework says is that you expect to receive, you expect that the value you receive from continuously delta hedging should be offset completely by the theta. But it's not the theta just on the options. So we can look here, we've got the theta on the options. It's actually the theta on a delta hedged portfolio. So we have to hedge our delta, and we have to manage our cash. So we can't have a cash balance in that. So the first thing we need to do is delta hedge. And you can see here the delta is 636.83 shares. I'm going to go ahead and book, and I'll round to the nearest share. So that's negative 637. We trade at $100 per share. We book that in, and we can see our delta is pretty much 0. This is our standard long option delta profile. Okay, so again, that didn't change the theta. Shares don't have theta on them, but we have to manage this cash. So we have to, when we put on this portfolio, we paid for the options about $10,500, $10,450. And we receive $63,700. We can see that number here, or the opposite of that number here. So we received that much when we put on the share position. And so we're left with $53,249.42 in cash. We need to do something with that cash to accurately reflect our theta. So we click on our Borrow Zero Coupon Bond button. And I'm going to, it doesn't matter which one of these we do, we'll end up with the same answer. We can either borrow or lend, in this case, that money there, the $53,249. We could do that for a day, or we can invest in the zero coupon bond. I'll go ahead and do that. The zero coupon bond, here it has a maturity December 16th, 2025, which is the same as our options. And that's the most natural maturity to choose. But again, it doesn't matter which maturity we choose. The principal is the cash amount grown at the risk-free rate of 5%. So that's 55,979.58. And so we're just going to go ahead and book that zero coupon bond. We can see here we've done things correctly. Our cash balance is now 0. Now this is the portfolio. Now that trade changes our theta. So this trade, this portfolio is the portfolio that should predict how much money we make and lose from our continuous delta hedging activity. And it should be the opposite of the theta. So we expect to make or lose about $10.28 today from our delta hedging activity. Again, the way this works is we spend all day delta hedging. We make about $10.28. Tonight, we close our book, go to bed, wake up the next morning, change today's date to be the 17th of December 2024, and we lose that $10.28. So today this number creeps up to about $10.25. At the end of the day, theta kicks in and we lose that money again.